Hello, good morning, good afternoon and good evening, whichever time you will be watching this video. So we are going to do questions on probability in this video. This is revising KJSEA. This is grade 9 national exams. Now, probability comes under the larger topic of data handling and will come in around question 20 section A and question 38 and 39 of section B. So if this question will be on probability, the same paper section B will be about statistics. You can see this one is about statistics. So the next paper, if we find question 20. Yes, this is on statistics, question 20. So the same paper, question 40, will be about probability. So I want us to, and this question has many marks. You could find in section B a question taking as many as 5 marks. Now, let us go first on section, on paper 1, sample paper 1, and look for the question. So sample paper 1, page 7. Yes, so the first question, question 20 is on probability. And you want to know, let us read the question. A spanner has 5 equally likely sections colored red, blue, green, yellow, and orange. What's the probability of landing on a primary color? And you're told that primary colors are red, blue, and yellow. So if you have this spanner, you have red, green, orange, green, red, blue, and yellow. You are told, so we are going to spin this, and you can see you have an arrow. If you spin it, you are asked, what is the probability that the arrow will land on either red, blue, or yellow? So this is how you handle it. You draw there are three different ways. Okay, 2 different ways of doing it. There is a probability of getting a red. Remember, you have 5 colors: red, blue, green, yellow, and orange. So there is equal chances of getting all these. The probability of getting a red is 1 over 5 because there are equal chances and there are 5 possible chances. So this one is also 1 over 5, 1 over 5, 1 over 5, and 1 over 5. So you are being asked probability red or blue or green or yellow, sorry. This is the probability of red, add probability of blue plus probability of yellow. So you are going to add all these probabilities. So what is the probability of getting a red? 1 over 5 plus probability of getting a blue? 1 over 5. Probability of getting a yellow? 1 over 5. So your answer is 3 over 5. That is your answer. And in this book, the correct choice is C, 3 over 5. Let us look at another question on probability and see whether we can apply what we have learned there. So paper 2, sample paper 2, section 20 is statistics. So let us go directly to question 40. So we are told a number is picked at random. Let me rub this. a number is picked at random from 1 to 10. Find the probability that it is a multiple of 3, or so question section A, question 40A, find the probability that it is a multiple of 3, and B, a prime number. So it is important first to identify that there are two ways of doing this. You need to identify that the total number, the total possible chances from 1 to 10, there are 10 numbers, and we could write them just for the sake of demonstration: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, so what's the probability of A you have asked multiple of 3. So you need to find all multiples of 3, or numbers that can be divided by 3. So 3 first is a multiple of 3. You can consider it because you can divide by 3. Don't ignore it. This one, because this one is 3 times 1. This is 3 times 2. And this one is 3 times 3. So you have 1, 2, and 3. So how many multiples of 3 do you have? You have 3. Out of how many possible chances were you given? 1 to 10? You have 10. And this is your answer. Probability multiple of 3. You could write it well and say probability multiple of 3 is equals to 3 out of 10. Remember, it is not obvious that this was 3 and you write 3 over 10. If it was someone doing a guesswork, you need to demonstrate that you have this 3, 6, and 10. The second probability you are asked is probability a prime number. So probability prime number is equals to what? So you need to identify all the prime numbers here. So what is a prime number? Is a number that is only divisible by 1 and itself. You can only divide by 1 and itself, and 1 is not considered a prime number. So the first prime number is 2. The second prime number is 3. The third prime number is 5, because this one you can divide by 2, so 4 is not a prime number. 6 you can divide by 3, you can divide by 2. The other prime number is 7. You cannot divide by any other number here apart from 1. Number 8 is divisible by 4, by 2. 9 is divisible by 3. So how many prime numbers do you have between 1 and 10? You have 1, 2, 3, 4. Your probability that you get a prime number is 4 over the total number of the integers that you have here, the counting numbers. So this is how you handle that question. Can we look at another question on probability? Sure, we can. So that you prepare well on questions on this topic, probability. You need to prepare well such that you are sure any question that comes in your exams in this topic, you are able to handle it. So I'm going to go directly to section sample paper 3. Question question 40. Question 40 asks, a card is picked at random from numbers 1 to 20. Find the probability of a multiple of 4 and a number greater than 15. So you can write these numbers first. Well, in your exams, you can identify the numbers. You can go directly and say, so you have a card picked at random from numbers 1 to 20. Question A asks a multiple of 4. So you can identify multiples of 4 directly just looking at the question. But remember, this question has marks for the steps you are going to take. So it is important to write these numbers. Now, let me write the numbers first. So, 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, question A asks probability multiple of 4. So, from our question, from our numbers, the numbers that we have written here, you can underline or you can circle the multiples of 4. Or let us tick so that, okay, we can just write around a circle. So multiples of 4, you can start with 4, which is 4 times 1. You can go to 8. 8 is 2 times 4. This is 3 times 4. This is 4 times 4. And this is 5 times 4. So how many multiples of 4 do we have? 1, 2, 3, 4, 5. So your answer here is 5 over 20. And then you can simplify further by dividing by 5, 1 by 5, 4. So your answer is 1 over 4. Your final answer, 1 over 4. The next question asks, part B, a number greater than 15. So probability, you can say number greater than 15. So what do you understand by the word greater? Do you include 15? Remember, greater, we have not said greater or equal. So you are going to skip 15 and going to tick 16, 17, 18, 19, 20. So the question asks for that you have 20 numbers or cards indicated 1 to 20 and then umemix kabisa. So we are saying if you flip and you randomly pick one, what's the probability that the number you pick is greater than 15? So you count the numbers that are greater than 15, you add them 1, 2, 3, 4, 5. You say the answer is 5 over the total number of cards you had, 20. So again, for this question, the answer is, you divide by 5, 1 by 5, 4. The answer is 1 over 4. 1 over 4. So that is how you handle questions on probability. Now, can we look for another question? Yes. Sample paper 4. Yes, you have this question. A fair 6-sided die is rolled. What's the probability of rolling an even number? So, you have a fair. A fair. Fair means there's no greater chance. For example, when you have a coin and you flip, it is fair that you have equal chances of getting either a head or a tail. So hakuna nye at getting a head iko na higher chance, hiyo coin ikianguka itanguka to any side. So similarly, a fair-sided die is rolled and this die has 6 sides. What's the probability of rolling an even number? So we will, if you label the die 1, 2, 3, 4, 5, 6. So each side of the die has a number and you have rolled. So we are being asked what's the probability you are going to get. Probability even. So you need to identify how many even numbers you have in your question. So how many? You have 2, you have 4, and you have 6. So the probability that you are going to get an even is 1, 2, 3, 3 over all of the numbers 1, 2, 3, 4, 5, 6, 6, which is a half. Divided by 3, 1 by 3, 2. The answer is a half. You can see these questions are not very difficult. Can you? I hope you can concur with me. Right. Sample paper. That was sample paper 4. Sample paper 5. Sample paper 5. The question should be yes, question 40. Remember, this book has many questions in the NEC format of KJSEA exam. So you can get this copy from me. It goes for 350 and you can be delivered countrywide. Again, you have seen other guides on this channel showing how to handle the different questions. Again, it is important to note that the setting of the questions in this book follows the format provided by NEC, and therefore that is why you see it is very consistent that in each paper you will find a question on probability, and that is a sure topic that you'll find in your exam at the end of the year. So, question 40. Kamau drew a card from a stack of 15 cards labeled 1 to 15. Find the probability of getting a card that has a number divisible by 5. So, Kamau drew a number with these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we are being asked, find the probability that a number divisible, that if you draw a card at random, you are going to get a probability number divisible by 5. You need to look at, this question could be phrased as multiple of 5. So 5 is divisible by 5, 10 is divisible by 5, and 15 is divisible by 5. So the answer here is 1, 2, 3, 3 over the total number. All the numbers here are 15. You can subdivide or can simplify further by 3, 1 by 3, 5. And therefore your answer is 1 over 5. It's your final answer. Part B asks a number less than 5. Probability number less than 5. You don't need to write like me, but it is important. This is good. You are trying to simplify this. You don't write everything. You could say number less. You write the less like this than 5. But mine is also good. It's actually better. So probability number less than 5. Sorry, not less than 5. Less than 4. Here is the question. Less than 4. Less than 4 is 1, 2, and 3. So the question is less than 4, not 4 or less. So you're not going to include 4. Again here you have 3 over 15. 1, 2, 3, and all of the possible, or the cards you had are 15. So again, if you simplify, you get 1 over 5. Simple, right? Very, very simple. Now we are going to skip some of the sample papers and look for more at the back. So this question is also not difficult. For the probability that the number is divisible by 3 or a prime number, that's not difficult. It's similar to what we have done. Yes. Now, this is we could make a question out of this question. I'm going to make one. Yes, let us make another question out of this. This one is asking about drawing a pie chart, but we can make this a question on probability. For example, you are told the number of students participating in different clubs in a school is recorded as follows. So club and number of students. In the debating club, you have 25 students. Chess, you have 15 students. Science club, you have 30 students. Drama, you have 20 students. Photography, you have 10 students. The question asks that you represent this one in a pie chart. But now suppose this question asks, a teacher picked a student at random from this school. What's the probability that the student is in so assuming that each student there is no student joining two clubs, so what's the probability that the student is in chess club? So probability chess. So a teacher has just come to school and has taken a student at random. So when you are given this, you say probability that the student is in chess club is the probability the total number of students enrolled in chess, 15. You take 15 over the total number of students in the school. You add 25 plus 15 is 40, plus that is 70, plus 20 is 90, plus 10, 100. So your answer would have been 15 over 100, sorry. You divide by 5, you have 3 over 20. So that is the probability that a student picked at random is in chess club. What about the probability that a student is in photography? Probability photography. The answer is students in photography are 10. The lower row, you have 10 over 100. So your answer is 1 over 10. What about if we made this question to be probability chess or photography? So what's the probability that the student picked at random is either in chess or photography? You add the number of students in chess and photography. 15 over plus 10 is 25. So you have 25 over 100. So this is actually a quarter. And this one actually means a quarter of the students in the school are doing photography. Another method of doing this is that you can take the number of students, the probabilities you have. When you see the word or, it means you are adding. So you will take alternatively probability, let me write in abbreviations, probability chess or photography is equals to probability chess plus probability photography. Okay, so you're going to add the two probabilities we have above. So this one was 3/20 and this 1/10. When we add, we expect this answer. So you will have 1/3/20 plus 1/10. What's the LCM? The LCM is 20. And you have 20 divided by 21 times 1, 3. Plus 20 divided by 10, 2. Times 2, 2. So your answer here is 5/20, which simplifies by 5, 1 by 5, 4, which simplifies to 1/4. This answer is the same as this. So it is important to understand how these questions work and why we are doing what we are doing at each stage. So thank you for following through this topic on probability, and we hope that it has been of help. Comment below this video so that we can know whether there are areas you need us to improve and whether you have understood. Also remember to subscribe to this channel and get yourself a copy of this book by myself, Victor Maura. Bye bye.